and welcome to part two of this three-part lecture on diseases of the nervous system. Again, this is part two of this three-part lecture. So let's get started. Listeriosis. Listeriosis is a gram-positive aerobic rod or bacillus. This would be rod-shaped bacterium. Excreted in animal feces, then enters the soil and the water, and then it gets consumed from there. So it gets out into the environment through the feces and then gets into the dirt, in which another animal then will chew the grass that has the infected feces on it or drink the water that has the bacteria in the water, and then they will contract not that they will, but they could contract listeriosis. It's usually foodborne for us, and it can be transmitted to the fetus and can lead to a spontaneous abortion or stillbirth. And that's just not in humans, I should specify, but this would also be in other mammals as well. And what's interesting about these bacteria is that they reproduce in phagocytes. And so even though they're within these cells that are supposed to be breaking them down and phagocytizing them, they actually can reproduce in them, and they can be passed from one white blood cell to another one. Fully intact, surviving. Sometimes invades the central nervous system, causing meningitis, and that's why this bacterium, that's why I'm mentioning it in this chapter, because it can get into the central nervous system and cause meningitis, usually though in immunosuppressed, or into the bloodstream, which can cause sepsis. If you want to see if it's in the central nervous system, you isolate, culture the blood if you want to see if it's within the bloodstream, or you do a lumbar puncture and look at the cerebrospinal fluid to see if the bacteria are present. In the United States, there are about 1,600 cases, about 260 deaths per year in the United States, and it can be treated with penicillin. So here's one bacterium that can actually be treated with penicillin or an antibiotic that is some derivative of penicillin. So here you have the bacterium called Listeria monocytogenes, which is being transferred from one macrophage, the macrophage on the right. It's being transferred from that guy to the macrophage on the left. So these are two large macrophages, big white blood cells, and it's being transferred from one to the other, and then they can reproduce within the macrophages as well. And so this makes them a little tricky, and as I said, it can get into the cerebrospinal fluid and cause meningitis. Tetanus, caused by the bacterium Clostridium tetani, and it's found as spores in the soil, and it's a common soil bacterium. It's gram-positive, and as spore forming, it's an obligate anaerobe, so no oxygen. Oxygen is lethal to Clostridium tetani. It grows in deep wounds, and so therefore these bacteria get inserted into the body through puncture wounds. They get put deep into the skin and into the dermal layer or even the subcutaneous, and then the skin seals around it, prevents oxygen from getting in, and then they can start to grow and multiply and divide, and then they'll release a neurotoxin called tetanospasmin, released from dead bacterial cells. It blocks the relaxation pathway in muscles. So this toxin that they're producing, it's an exotoxin from the dead cells. The muscles then cannot relax. It blocks. It gets picked up by receptors on muscle fibers that prevents them from relaxing and undergoing the relaxation pathway. Death results from spasms of respiratory muscles, so you're going to have skeletal muscles being affected first. Of course, we call this nickname as lockjaw, so you feel the signs of it in the muscles of your jaw, and it starts to get tight. That will then eventually lead to spasms of skeletal muscles in the body, and then it'll eventually hit respiratory muscles. It'll also get into cardiac muscles as well. And then, of course, the heart can't beat, the diaphragm cannot work, and therefore you're not able to breathe, your heart is not able to beat, and death will result. It's prevented by the toxoid vaccine, and so we've developed a vaccine that is like tetanospasmin, but not the same thing, but it's close enough that we'll develop antibodies against the toxoid, which will also be effective antibodies against the actual toxin of tetanospasmin. And that's the prevention. If you develop tetanus, you are given treatment with tetanus immune globulin. So these are antibodies. This would be artificially acquired passive, where you are given a shot artificially, and it's passive. You are not forming the antibodies. The antibodies have already been formed for you, and the reason why this is done is because you don't have time. You don't have time for your primary response to kick in, because by then you're probably going to be dead. And so in the case of tetanus, as the same with rabies, if you have an active rabies infection, the doctors are not going to wait around for you. They're not going to give you a vaccine. They're not going to do anything. They're going to give you that, yes, but they're also going to give you the active antibodies as well. Because there isn't enough time for your body to be introduced to the vaccine and then for you to develop antibodies. And that in some cases takes 2 weeks. And that is, by then, the disease could be very severe. Irreversible damage or death could be a result of this. So you're given the vaccine along with the immune globulins as well. Newborn cases occur because severed umbilical cords are dressed with soil, clay, and of all things, cow dung. Why? I don't understand. But so whenever a child is born, the severed umbilical cords, they dress them with that. They use that to protect it in some way. But anyway, these bacteria are growing in the soil. They're growing in clay, they're growing in cow dung as well, and so unfortunately then the bacteria get into the bloodstream through the open umbilical cord wound, and then that leads to tetanus within the newborn. Annually worldwide, there are about 1 million cases of it. This is a painting of a British soldier by Sir Charles Bell. He was a Scottish surgeon, anatomist, physiologist. He was an artist. As you can see, it's not a pretty good painting here. But you can see the effects of this. This is during the Napoleonic Wars, and a British soldier is getting into the advanced stages of tetanus. Of course, this was before we had any kind of immune globulin treatment or toxoid vaccine. When you developed tetanus, that was it. There was no recovery from it. So the disease would just progress further and further and further until the whole body goes into this spasmic posture, and your muscles are continually contracted. This guy won't be around. I'm sure he wasn't around much longer after this point. Cousin to Clostridium tetani is Clostridium botulinum, a gram-positive endospore-forming obligate anaerobe, same characteristics there as tetani, found in soil and freshwater sediment as well. So this is a soil bacterium as well, and it produces the most potent exotoxin, and it's a neurotoxin just like tetanospasmin. It is the deadliest substance that we know of, natural or synthetic. It is the botulinum exotoxin is the deadliest substance mankind knows of. And it's a toxin that blocks the release of acetylcholine, which is a neurotransmitter that gets picked up by muscle fibers, and it causes what's known as flaccid paralysis. And if you Google image that, you should be able to find some pictures of it where you just kind of, it's like a flopped position, but it's a paralytic position. So you just flopped over. It's kind of like, in some ways, the opposite of the tetanus spasms, where they're tight contractions. In this case, the individual just kind of flops, and then you're in that paralytic state. Same reason for death, respiratory and cardiac failure, because those muscles then aren't able to enable breathing or heartbeat. And there are 3 types: food botulism, wound botulism, and infant botulism, which we'll talk about here. So what are some of the symptoms of botulism? Double vision, blurred vision, drooping eyelids, slurred speech. You see, because these muscles aren't able to function properly. Like with the case of tetanus, you have the lockjaw. Your jaw muscles become tightened, and they start to not be able to relax. Here you have ocular muscles not working properly. Your tongue isn't working properly. The muscles that enable us to swallow and carry out peristalsis aren't working properly. Dry mouth, because you're not able to contract salivary glands and the muscles that are surrounding them, and muscle weakness as well. So treatment, supportive care, and the antitoxin. Infant botulism results from the bacteria growing in the intestines, and so the normal microbiota have not yet been established, and so the infant is introduced to Clostridium botulinum bacteria, and they grow within the intestinal tract, and there aren't normal microbiota to carry out antagonism against them, so they grow. Wound botulism from the growth of bacteria in wounds, so kind of like with the case with tetanus, where they dress the umbilical cord with soil, clay, or cow dung. Wound botulism is kind of the same route. Local injections, however, of the toxin Botox injections, go to a plastic surgeon, and you can have Botox injections given to reduce wrinkles, prevent armpit sweating, which maybe I should look into that. No, just kidding. And control excessive optic muscle contractions. In cases where there are issues with the optic muscle contractions, this can lead to the relaxation of them due to some other disorder that a person may possess. So you say, well, these injections, you're getting an injection of the deadliest substance known to man. So how can we do that without killing a person or causing them to develop botulism? It's the preparation, it's how it's administered, it's what has been actually done to the toxin that has, it's obviously in a very small amount, but there's been some manipulation done to the toxin so that it doesn't cause actual botulism itself. Leprosy. I'm sure you've heard of leprosy. We have leper colonies, and it was a term that was historically used to classify a number of skin diseases, many of which were not specifically leprosy. But now we have the specific disease of leprosy caused by a specific bacterium. It's a rod-shaped bacterium, a bacillus, that grows best at 30 degrees Celsius. So in the extremities that's where it best grows. It'll grow in peripheral nerves and in skin cells. And growing in the peripheral nerves, it causes the skin to become sensitive. You develop this tuberculoid form where you lose sensation in the skin area, so you have high sensitivity and then the loss of sensation as the infection progresses. It's resistant to phagocytosis, and it invades cells of the myelin sheath. And that's why this disease, we often think of it as just being a skin disease, because that's how it manifests itself. It presents on the skin. But actually, what's going on behind the scenes under the skin, it's invading peripheral nerves and getting into the cells of the myelin sheath. Those would be the Schwann cells that compose the myelin sheath of the peripheral nerves. Transmission requires prolonged contact with an infected person or an armadillo. And you say, armadillo, what's up with that? So armadillos, they're mammals, and their blood temperature is right around 30 degrees Celsius. So perfect growing conditions in terms of temperature for these bacteria to survive and live in. Transfer through nasal mucosa, complications, especially with tuberculosis, can cause death. Tuberculosis is rampant. There are currently about 2 billion people that have active tuberculosis infections around the world. And so you can see how where there is a lot of TB, there's going to be increased incidences of leprosy as well. The tuberculoid form, there are two forms, I should say, tuberculoid and lepromatous. Tuberculoid form causes the loss of sensation in the skin areas, and it looks like a tuber, and that's why it's called tuberculoid. It's like that. It forms these masses, and I shouldn't say masses, but these regions in the skin you'll see on the next picture that are red. And it kind of looks like maybe it's kind of these tubercles, or presents itself like tuberculosis in the lungs, for example. The more progressive form, the lepromatous one, that causes disfiguring nodules over the body, especially on the extremities. The fingers become disfigured. They become these little nubs. It breaks down soft tissue and bone tissue within the hands, within the fingers, and it causes these disfiguring nodules all over the face. It's treated with drugs and vaccines, and the treatment is very effective with it. However, we have about 500,000 new cases annually because these people just don't have access to proper health care. And so they develop leprosy, and it's a shame that they don't get the treatment because, like I said, the treatment is pretty effective. So what's going on with Leprosy and armadillos going to man. So leprosy, which this graph shows, it's brought to the Americas by European immigrants about 500 years ago, gets transmitted to armadillos, the only known case of non-human infection. So we are the only reservoir for it outside of the armadillo, and now they have it. So it's become endemic to armadillos. Um, in the United States, there you can see on that map of the United States where the cases are. And notice these are, you read their sites where infected armadillos were sampled. So these are just where we found infected ones, where they were sampled in a particular study, but there may be many, many more because those areas just haven't been researched and those armadillos haven't been sampled. But we found it there in Texas, Louisiana, Arkansas, Mississippi, and so on. So these are where we're finding the most number of cases of infected armadillos. So if you go down to that region of the country, you might not want to cuddle up with an armadillo because you might develop leprosy from it. Not that you would want to cuddle with an armadillo. They're not exactly cuddly creatures, I suppose, but I don't know. We each have our own preferences. Some people think snakes are the cuddliest things on earth, and maybe people who really think snakes are adorable might think an armadillo is adorable. I don't know. But anyway, you might want to stay away from them when you go down to that region of the country. Just a little bit of friendly advice. This is what it looks like. You can see the tuberculoid leprosy. These are just causing skin lesions, these red rashes on the skin. The lepromatous, this unfortunate individual here, you can see these disfiguring nodules that just destroy the tissue and cause this inflammation, and yeah, sadly this could have been prevented. Polio or poliomyelitis. And so we often just shorten it to just polio, but the full name of it gives you what's going on here. Poliomyelitis. So it's causing inflammation of the myelin sheath around the nerves. It's transmitted by ingestion of water-containing feces with virus. So this is transmitted via what's called the fecal-oral cycle, where the feces gets into the water supply and then people consume the water with the infected feces, with the feces containing the virus inside it. Initial symptoms: headaches, sore throat, fever, nausea. So these are all, I'm getting the flu. Nope, it's not the flu. And death as a result of respiratory paralysis. Of course, as you know, with polio, it's not just respiratory paralysis, as the progression of tetanus and botulism, where it starts out, especially tetanus in the skeletal muscles. Polio, same thing, starts out in the skeletal muscles. The affected individual can't walk, and then eventually it leads to and spreads into respiratory muscles and leads to respiratory paralysis, and the individual can't breathe then. Viremia may result if they get into the bloodstream, and if persistent, the virus can enter into the central nervous system. Destruction of motor cells, the ones that enable us to move, and paralysis occurs in about 1% of cases. So the peripheral nerves that are servicing the muscle, then that's why the skeletal muscles are the ones that are first affected and seen. Prevention is by vaccination. The vaccination was remarkable. It was incredibly successful as well when it was administered. The iron lungs, and so these were the children were kept. This would have been in the late 40s, early 50s, where they weren't able to breathe on their own, and so they were put into these large cylinders that had bellows on one end, and they would just keep moving back and forth, creating negative and positive pressures within the iron lung itself, and that enabled, it was basically breathing for the child as he or she was inside of it. And you can see on these iron lungs that they put mirrors over them so the kids could actually see themselves. And I mean, what an awful way to live inside of these. From polio came you may have heard of the March of Dimes. So this was a time in our nation's history when we were very concerned about this. We thought it was spread by mosquitoes, and so we were using all kinds of DDT and mosquito sprays in neighborhoods, which it was not transmitted by mosquitoes at all. But that was our assumption, and it was wrong. So what happened was we noticed that it was spiking in the summer months. And why was it spiking in the summer? Was it because the temperatures were warmer? What was going on? It was discovered that when we realized what it was, that it was transmitted via fecal-oral cycle, children swimming in public swimming pools, which were much more common in the 1950s than they are today. People just didn't have their own swimming pool in their backyard. And so communities had their community swimming pools. And so children, of course, would go there and swim. And while they were there, they had to go to the bathroom. And so they would go do their business in the bathroom. They weren't very careful about taking care of the paperwork, wiping up after themselves, washing their hands, anything like that. So they would go to the bathroom and then run right back into the pool, and they would bring fecal matter with them from themselves, and as the fecal matter with the viruses would be disseminated into the water, and then children would be swimming, take a gulp of water with the virus in them, and then that's how it was transmitted, unfortunately and sadly. And so we developed this. They would have marches, like parades, through towns, and they were called the March of Dimes. And at that time, a dime was worth something, a little bit, and they tried to appeal to the kids. And so the kids would say, give their allowances that they were given a few dimes. And so that was their plea. If you could just give us a few dimes, that's all we need, just a few dimes, and we can make a difference. And so they would go through neighborhoods and towns, and people would give their dimes, and they started calling these the March of Dimes. And so dime by dime, dollar by dollar, they collected all this money in order to lead to a vaccine that was developed by Jonas Salk and was first administered in 1954. And Jonas Salk, he was working at the University of Pittsburgh, and that's where it was developed. There was a lot of pressure that was placed on this because kids were dying from this disease, and this was right after World War II, and the United States was on top of the world, and this disease can't stop us because we're number one, and it's devastating our children, and many Hollywood got involved, and many actors and actresses were contributing in different ways, making it was an incredibly public campaign. And it was across the United States, and everybody was everybody was pulling together their resources for Jonas Salk, and he then became like Superman. They Everybody had their eyes on him. He was like Obi-Wan Kenobi, you're our only hope. And so he and his team at the University of Pittsburgh were working day and night, till eventually they developed an effective vaccine, and it was mass administered then. And Salk himself, he inoculated, sorry, not inoculated, he vaccinated his own children first to prove that it was a safe vaccination, and a safe vaccine. And then once that happened, he actually administered many vaccinations himself. He went into public schools and delivered the vaccinations himself. He was a remarkable guy. And then later, Dr. Sabin, he made an attenuated vaccine. So Salk made the inactivated one, and he felt that was safe enough. He didn't want to use the weakened one because he said that was getting too close to the actual virus, and he didn't want to create disease in those who were vaccinated. So he um, he remained with the inactivated vaccine, which was very effective. The attenuated vaccine was also very effective as well. And you can see again from this graph, whole bunch of cases before the vaccine and then like no cases years later. So as the number of doses started to increase, the number of cases decreased again precipitously to where there was like none in the early 2000s. So another prominent success story in the history of vaccinations. This was a very effective vaccine. Okay, that's the end of part 2 in this 3-part series on diseases of the nervous system. Please stay tuned for part 3, and thanks for watching.